Probably the most common reaction of Grignard and alkylithium reagents is their addition of the carbonyl compounds. This addition starts with an attack of R-, and R- is derived from alkyl magnesium halide or alkylithium compound onto a carbonyl bond in the carbonyl compound. Initially, this gives us an alkoxide which is then protonated to give us an alcohol. This is a so-called Grignard reaction, and it is one of the most versatile applications of Grignard reagents, as well as one of the most versatile preparations of alcohols, because it can be virtually used to prepare any kind of an alcohol. To illustrate that, addition onto formaldehyde will give us a primary alcohol. After workup with acid. And if we try this with, say, phenylmagnesium chloride and formaldehyde, we will get benzyl alcohol in close to 90% yield. Addition to other types of aldehydes will give us secondary alcohol. An example here could be addition of benzyl magnesium bromide to, say, butanol, which after workup will give us an example of secondary alcohol shown here. Okay? Finally, if we add an organomagnesium compound onto a ketone, we will initially get an alkoxide of a tertiary alcohol, which is upon hydrolysis converted into tertiary alcohol itself, again in very high yields. This is an example. We take a pentanone and we react it with propyl magnesium halide to get a compound like this. Now, one word of caution is that with tertiary alcohol, the final step is acidification to get the alcohol. And we have to be very careful here, because if we add too much acid, the thing that happens often with tertiary alcohol is that it leads to dehydration and the production of alkenes. And so this is typically done with very mild acids such as ammonium chloride and so forth. Now, all of these reactions are the most common ones. Grignard reagents, as well as organolithiums, react with acid chlorides and as esters and epoxides as well. And so we're going to briefly discuss those reactions too, since they're mechanistically a little more involved. And so if we have an acyl chloride, where a carbonyl group is substituted by one alkyl group and one chloro group, then initially we will get an addition to give us species like this. But now the difference here is that this oxygen can back attack and remove chloride. Unlike alkyl groups, chloride is a good leaving group. And so this gives us a ketone. Okay? Now a ketone is again attacked by organomagnesium compound. To give us a tertiary alcohol, but now, and finally after protonation we get tertiary alcohol, but now the difference is that in our tertiary alcohol, two of the alkyl groups come from from the Grignard reagent, and they're the same, while just one comes from the original carbon compound. And this is a difference compared to the additions onto aldehydes and ketones. Alternatively, the similar mechanism would be operational if we react this with esters. Giving us O- here, OR prime and R2, and an expulsion of R prime gives us back our ketone, which is then reacted to finally give us tertiary alcohol with 2 alkyl groups on here. Okay. Now, an example of this reaction could be reaction of ethyl benzene carboxylate with phenyl magnesium bromide. And this simple reaction, at the end of the day, gives us triphenyl methanol. So this is an example of very crowded alcohol. Okay. Finally, the reactions with epoxides are also very useful. We mentioned already that epoxides are very useful synthetic intermediates since they can be easily opened. And indeed, the Grignard reagents will open them up and get us to this extended alcohol, which is then hydrolyzed. And so what we see overall is that we added this C2O unit onto our Grignard reagent, which is a very useful building block. To illustrate this, if we react phenyl magnesium bromide with just a simple ethylene oxide, after workup, we will get this phenylethyl alcohol, which is a precursor to amphetamines, among other things. So to sum this up, Grignard reagents are remarkably versatile. They most often act as carbon-based nucleophiles, and they're versatile to the point that almost any carbon-based group can be converted into Grignard reagents and then made nucleophilic. As nucleophiles, their main reactions are attacks onto carbonyl compounds, which give alcohols, and these carbonyl compounds can be aldehydes, ketones, chlorides, esters, and so forth, or addition onto epoxides, which not only add an alcohol but extends the chain by 2 carbon atoms. However, the high reactivity of these Grignard reagents comes with a price, in that oftentimes they undergo undesired reactions. And in the next subsections we'll see some of those undesired reactions.